Hello students, so this is from Hessian Matrix. Now today we are going to learn about this part which is called as Hessian Matrix. And in this is specifically important for your regular BSc students, for engineering students, and most of all for the machine learning. That is the most important Hessian Matrix. Now we are well aware of the fact that we have learned that maxima. In before this we have learned maxima and minima. In this case, we are using the derivatives there. What derivatives? We are using dy by x, the differentiation, dy by x, and second differentiation with the d2y by dx square. So these two derivations we were using for getting maxima and minima here. Okay, this was our origin. Now in this case, what we are going to use? We are going to use a partial differentiation. While we will be using the partial differentiation to get the maximum minimum point, specifically for 2 dimension and 3 dimension. So let's begin. We'll continue with this. Let's see. Now, first part is that let's go for now. What is Hessian matrix? It is square matrix of second order partial differentiation. Scalar value function. What happens? It captures local curvature of function and used in various fields like optimization, machine learning, and image processing. These are some of the examples. See now in this case, we will be using second order derivatives. What derivatives? The partial. It is dou to partial differentiation. Second partial differentiation. Dou to f upon dou x square. Dou to f upon dou y square. The second differentiation for second differentiation for dou x with respect to y. Now, what is partial differentiation? For that, you have to go for my another videos on partial differentiation. We will be learning with that. Don't worry. So let's first know local curvature. Let's understand some of the why it is where it is used now. Now, understanding local curvature of function by analyzing eigenvalues here. Eigenvalues, you are well aware, the matrix, the eigenvalues and eigenvectors. You can determine the critical point. You know, where is the when first derivative is 0. If you remember, we were taking the differential dy by x equals 0, and then we were getting the values of x, two values of x. We were substituting those values, and we were using the if second derivative test, first derivative test. In second derivative test, we had that if d2x by d2 sorry d2y by dx square, if this is greater than 0 and less than 0, and those were the conditions where we were taking the we are getting minima or maxima, minimum point, we were getting minimum point or maximum point. These are the some of the parts what we have learned before. Now this is the further stage where we are using partial differentiation of second order derivative, second order but partial differentiation. Well, there will be a specific procedure for this. Okay. Now let's go for what are its application. One is optimization, where it is crucial for finding local minimum or maxima. It helps in algorithms like Newton's method to cover fastback curvature information. Most important, now this is very, very important, where right now it is in demand, that is machine learning. Machine learning, Hessian matrix is used in training neural network and other models, particularly in optimization techniques like Newton's method here. Okay. Image processing, best used in image processing to enhance certain features like vascular structures, analyzing. So Hessian matrix of the image, we will be taking Hessian matrix of image and then image processing. In that specifically, the medical field or general fields, it is we are using this for the image processing. Okay. Now let's go with our mathematical part. What is Hessian matrix? How it is written? Now Hessian matrix of second order partial derivatives. Now, suppose the function with r raised to n belongs to R. So, nth space, vector space r raised to n. Now, this is r raised to n. The vector space will be for, if we will consider matrix, in that matrix, the elements. Now, see, these are the elements we will be writing here. So, second differentiation, what x1, second differentiation x1 and x2, second differentiation up to xn. This is for nth space, so vector space n, n space. Yeah. So, what will it will be 3, 4, 5. Now, like that, we are continuing with the column. Column, we are going second differentiation with x here, and second column goes with as usual. It will be we are continuing with the second differentiation f in second column also till we are reaching the second differentiation of x raised to n. This is the basic format for Hessian matrix up to f function f for n variables. This is function for f variable. Now to make it more simplify, let's think of this one simple example with two variables. Let's go for a second vector in second space there R2. So how will be writing? Very just see it is very easy and simple. Second partial differentiation for with respect to x2. Second partial differentiation with x1 x2 means here we will be taking y here. Function is with x and y. So dx dy here. Second differentiation. Here we are taking the same again. for x dx dy, and second differentiation with y here. So we can go with partial f of xx, f of xy, f of xy, and f of y with respect to y. These are how the differentiations will be getting here. Now, see the determinant of Hessian matrix. Now, what is the concept for two variable function? If you go with determinant of this Hessian matrix, you will be getting the determinant is f of cross product there minus f of x whole square. This is what the final discriminant. We will call this determinant of this as a discriminant of f of x y. We will call this as discriminant. We are finding determinant, but after getting determinant, whatever the values of determinant, like formula what we are deriving, we will call it as discriminant of Hessian matrix there. Okay. So determinant of Hessian matrix. Don't get confused the words. Remember, determinant of Hessian matrix is discriminant of that function. We'll call that discrimination. Many times, if you remember, this is the delta, what we are using for discriminant. Delta or D is many times it is used for discriminant of this. Right? Now let's begin with one example. Now suppose we want to calculate a Hessian matrix for 0.10 multivariable function. So I'm taking this function in this case. So what will be first differentiation here? It is 3x square minus 6x minus 4y. Well aware of the first order partial derivative. If you are not aware, if you don't know, go check my videos for first order partial derivatives. Okay. So we will be getting first derivative partial differentiation 3x square, 6x and minus 4y. And with respect to y, I am getting 4y cube plus 8y minus 4x minus 5 from this origin function. Now, second differentiation of this will be 6x plus 6, 12y square plus 8. Second differentiation for y, second differentiation for x. We will be getting these two values. Now, second differentiation of dx with respect to y, d2f upon dx with respect to y. That means we are considering this value, this here, this part. This will become 0, this will become 0. What is left? Minus 4. Okay. Even in this case, if we are considering this second part, y4 y cube minus, if you are differentiating this value, that is second differentiation with dou y into dou x. Normally some students say kappa also here. So the second differentiation dou 2 f upon dou y into dou x with, so this first differentiation, when we are taking second partial differentiation, what we will be getting, just remember what will happen in this case. This is going to become 0, this will be your 0, this will be your 0, this is a constant 0, and this 4x, this will become minus 4, this will become minus 4 into 1 there. Differentiation of x is 1, so we are getting another minus 4. Got this second differentiation? Now, next part goes, we are writing in the Hessian matrix according to our formula, given format, what we call. So, to write this, just we will be writing as usual here. Here I am taking 6x plus 6, what we got second. And here these two are similar. So I'm writing here also minus 4 and 12y square plus 8. This will be your another second differentiation. Now they want matrix evaluated at 0.10. So what will be the final conclusion? Now we are substituting x as 1 and 0 as y. Substitute these values, you will get minus 4, 12 into 0 square plus 8, 6 into 1 plus 8. So this is the final 12 minus 4 minus 8 minus 4. Now here in this we will observe this matrix. The condition is that it should be either positive or all should be negative. All elements should be positive or all elements should be negative to get minimum or maximum. Right? Minimum or max, min or max you will be getting if all are positive or all are negative. But here it is neither positive nor negative. But here it is inconsistent or no conclusion, inconclusive. Here it will become inconclusive. For the given curve, given function of x, it is inconclusive with this Hessian matrix. We cannot get as the maximum minimum. These two are negative and these two are positive. This will be our final conclusion regarding this function. For more updates and that, please watch my videos. Thank you.